This is the 2015 section B3 question on perspective drawing. I'll start off by saying this is a very awkward drawing to set up because it's very big and it just about fits on the page. We'll get to that in a few minutes. Pictorial, so figure B3 shows the outline, plan and elevation of the greenhouse based on the graphic on the right. A pictorial view of the structure is also shown. Draw the given plan and make a perspective drawing of the structure given the following. Now, this statement is extremely important. It says draw the given plan. It didn't say anything about drawing an elevation. In other words, you don't have to draw the elevation. They don't want you to draw the elevation. It's not needed. And it'll only basically waste time. So always keep an eye out. What are they telling you to draw? If they said draw the given plan and project an elevation, that'd be totally different. Our information. Spectator is 4.5 meters from corner A. Picture plane is touching the corner A. Horizon line is 3.25 meters above the ground line. The door and window are in their closed position, and we have to use auxiliary vanishing points where appropriate. You don't need to include hidden detail. Very important down here. Scale is 1:50, so make sure you read through the question fully before you attack a question. That means looking at the scale, look at all these measurements, look around down here for any extra information that's given. We need to get a scale of 1:50. This is the awkward part of this question. 1.5 meters is 1500 millimeters. So we have to first convert it to millimeters, then divide by 50. So in other words, 1.5 meters is 1500 millimeters divided by 50, because the scale of 1:50 gives 30 millimeters. 2.25 meters is 2250 millimeters. To convert these things, put zeros on, enough zeros on to get a 4-digit number. So what I mean by that, 4.5 meters. 4.5 meters, 4-5, and stick on enough zeros to get to 4 digits. It's 4,500 millimeters. 1500, 15, stick on the digits, and that's 1500 millimeters. And again up here, 4.5 meters, 4.5 meters is 4500 millimeters. This is 3250 millimeters. Get all those in millimeters first, then we divide by 50. So your measurements that you should be getting. Spectator, 90 millimeters from corner A. Horizon line, 65 millimeters above the ground. We've got measurements of 30, 30, 30, 45 up to the start of the roof. It's overall 120 by 90 in plan. So we've got all our measurements, and remember, we're only drawing the plan. When we get to the actual question, to set it up, stick it right up in the corner, up here in the left hand corner. Wedge it up into the corner so that you've got just enough space to set it out. To set up the question, we drew our plan, 90 by 120. Our spectator, at a 45-degree angle, it's 90 millimeters away, and then we've got our normal setup. So join the two widest points, bisect that angle to get our central vision line. It said the picture plane is touching corner A, which is at 90 degrees, so picture plane is drawn at 90 degrees to our central vision line. Our horizon line and ground line, I came down from the spectator, which is here, I came down 100 millimeters to put in my ground line, and then we measured up 65 millimeters to put in the horizon line. Our vanishing points, parallel to one side, vanishing point 1, brought to the perspective view. Our other side, which is horizontal lines, take our parallel line to get vanishing point 2, bring it to our perspective view. So both sitting on the horizon. So there are my two vanishing points. That is the setup for the question. Drawing the question itself after it's set up is pretty straightforward. So our corner A is touching the picture plane. That's where we start. So we project down our corner A parallel to the central vision line. I'll darken it slightly so you can see where I've drawn that. The height of corner A from the drawing was 45 millimeters. So I can measure my height and get that front corner straight away. Vanish back to vanishing point 1, top and bottom. To get the back corner, again, vanish back towards the spectator. Here's my back corner. and where it hits the picture plane, it's brought down. Bring it down, and we get our back corner. Vanish the other direction, and again, other corner towards the picture plane, project that down. And again, vanish our corner back, and I'm doing those lightly because they're not in yet. So that gives me the side of the greenhouse. That's the basic shape set out. We have to go and use vanishing points to get the shape of the roof. And we'll do that in a second. The question told us that our roof is rising each side 35 degrees. So 35 degrees is the angle I need. That's why we don't need the elevation, because they've told us the angle. So the angle of the roof, the pitch of the roof, 35 degrees. Those angled lines are here, up along, and here. So that is the two sides of the roof rising at 35 degrees. The direction of those is in the direction of vanishing point 1. So it's vanishing point 1 I'm going to be dealing with when I want to set up my auxiliary vanishing point. The pitch, 35 degrees, so I'll set out a 35 degree angle. We can do it up the way or down the way, it doesn't matter, I just don't want it to encroach in the drawing too much. So I'm going to come down the way 35 degrees. So I've marked off my 35 degree angle there. I need to build a right angle triangle here, so I just come off from my vanishing point 1 line at 90 degrees. So as I said, this is a 90 degree angle. If you found that tricky, you can just use your protractor to come off at 90 degrees from the vanishing point. And what that has given me is my auxiliary vanishing point height. This is what I was looking for, this height here. That is the height for the auxiliary vanishing point. You need to make a little bit of sense of what you're looking at. If you look at it, this side of the roof is rising up, this side of the roof is falling down the way. So there's a difference in the two. So I needed one set of lines for this side of the roof, and I need a different set of lines for this side of the roof. So we'll take the set that's rising up first of all. These ones here on the right hand side, I'll highlight them all in red in a second. They're all rising up. So as I said, I'd highlight them. These 5 lines are all rising up the way. That means they're going to rise above vanishing point 1. I take my distance that I worked out and I strike it off above vanishing point 1 down here on my line. That is the position of my auxiliary vanishing point, and I'll call it vanishing point 1. It means the lines on this side of the roof will all rise up to that auxiliary vanishing point 1. First thing I want to do is find the start point of each of those lines. Here is the start point of each line. So I'll bring them again always back to the spectator and down. So I'll take that point down in a minute, this point down, and this point down. So those 3 points come back onto my line in the perspective view. Alright, so I have the start point for each of those 5 points. They're all going to vanish to the auxiliary vanishing point 1. So here's auxiliary vanishing point 1. I need to find the apex of the roof. Again, here's my line that I'm rising up. Here it is. Here's the apex. Take my point to the spectator. vanish that and bring that down to my perspective view. And here it is. That is going to help me out massively, because I can vanish all of these lines up to vanishing point 1, the auxiliary vanishing point 1. My center, the apex of the roof, is a horizontal line. Again, its direction is vanishing point 2. So I can just easily vanish to vanishing point 2. And that gives me the whole top surface of the roof. That is the shape of the roof drawn in. To draw in the position of the door and the window. The door in plan is here, and it was in 30 and in 30 from each edge. So that is the two sides of the door in plan. To find those, again, back to my picture plane and bring them down to my drawing. That gives me one side of the door and the other side of the door. And the top of it vanishes back to vanishing point 1, and it should line up, which it does. So that's the door very quickly drawn in. My window at the minute, here's the start of it. Vanish back to my picture plane and bring it down. Here's the start of the window, and instead of finding the second point, I can just vanish that to vanishing point 2. And there it is. So that's the window and the door drawn in. We'll deal with part C before we deal with part B, because it's related to auxiliary vanishing points. So it says, on your perspective drawing, show the roof window when it has been opened through an angle of 70 degrees. They give an angle of 70 degrees because it means the roof window, which is here somewhere at the minute, when it swings round through an angle of 70 degrees, this is a straight line. So it forms basically part of this other side of the roof. In the last question, I set up an auxiliary point for these lines that were rising. The set of lines on this side, the other side of the roof, are considered to be falling. And the way we work it out, if we run up, this side of the roof is rising, then this side is falling. So it's the same for all the lines. This side is rising, this line is falling, 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 falling. So all of those lines are falling to the same vanishing point. Back to our auxiliary vanishing point height that we worked out. We can measure that height above the line, which we marked here. So we marked that above the line because the lines were rising. So above our vanishing point 1, we measured up that distance because those lines were rising. Alternatively, we could measure those below the line if the lines are falling. So what I can do, and I'll just zoom in a little bit now, sorry. I'll continue my line here, and instead of taking that measurement and measuring it above the line, I measure it below the line. So originally we measured above VP1 because the lines were rising. Now I can come along and measure below the line because the line is falling. So we have auxiliary VP2. And that line can be used for any of the other sides of the roof. And you can see it there. I can draw in the apex of the roof here by vanishing to that vanishing point. It also means I can draw in the other lines on the roof. So if I come along and I take this point and this point, I can vanish up the way and vanish up the way. And that's giving me the angle of the two lines I need. What I need to do now is figure out where they stop. Now it'll be very hard to figure out on your own, and especially in a Leaving Cert exam, but this window, because it rotates through 70 degrees, they said, it's sitting in exactly the same position when it's open and when it's closed. So the plan view looks the same. So I can take down the same point to draw that in. So if I take down my point as we did before, its new position is directly above the old position. So the 2 points line up. And I can vanish back to my other vanishing point to finish that off. Part B then, the door has to be swung to an open position that's parallel to the picture plane. So what that means, hinges here on this side, we swing it open. And it's set to a position parallel to the picture plane. Here's the picture plane. Its position is going to be parallel to that. So here is my open position. We need to draw that in perspective. Again, something you wouldn't know off the top of your head. Any object that's parallel to the picture plane is going to have horizontal edges. They're not going to vanish to vanishing points. So it means the top and bottom of this door are going to actually be horizontal. Horizontal in my perspective drawing is parallel to my horizon. The horizon is horizontal. So what it means is the bottom edges of this door, and I'll just move down a little bit so you can see. The hinges here, and that isn't going to move. So I've got my top and bottom of the door. It means that I can come out horizontally, which is parallel to the horizon line, and again parallel to the horizon line. Here's the end of the door in the perspective view. We vanish back towards the spectator and take that point down. And that lets me draw in the door in the open position. Now, those two final parts of that question are extremely difficult, and I wouldn't be overly concerned about getting those in the Leaving Cert exam. If you got the entire shape of the greenhouse drawn, you'd be doing very, very well in the question.